So today we are going to discuss Kinetics Past Papers, right? So this is Unit 4 Edexcel. Question number 2 says the decomposition of ammonia is catalyzed by tungsten metal. The reaction has zero order kinetics. What is the rate equation for this reaction? So they are saying the reaction has zero order kinetics. So, zero order means what? Zero order means when you are going to increase or decrease the concentration, so the rate is not going to change. So, what do I say for this reaction? I would say that rate is equal to K and concentration of ammonia, but they are saying this is zero order, and we know that anything to the power 0 is 1. Anything to the power 0 is 1, so k into 1 is k, so rate is equal to k, right? So option A is correct, isn't it? If you are thinking, sir, the 2 is written with the coefficient of ammonia, why we are not considering it? If you remember, I told you that the order of reaction is related to experimental details. I cannot predict just after looking at the equation whether 2 is written, whether 1 is written, whether 3 is written. No, it depends on the experimental data. So they told us in the question the reaction has a zero order kinetics. So I would say it's zero order. Zero order means 0, and anything to the power 0 is 1. So that's the reason the answer is A. Okay. What are the units of the rate constant for this zero order reaction? So they are asking the unit for K. K is equal to rate. K is equal to rate, and we know that rate is equal to mole per dm cube per second. Mole per dm cube per second. So the answer is C. So that's why the answer is C. Simple, right? Which of these graphs represents this zero order reaction? So rate versus concentration. Rate versus concentration. When I would increase the concentration, when I would increase or decrease the concentration, so the rate would not change. Remember about the zero order reaction, when you will be changing the concentration of reactant, so the rate would not change. So means A is correct. Why? Because let's say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So continuously the concentration is changing, but the rate is not changing. The line is straight. Means that this is zero order reaction. Okay. Which continuous monitoring method could be used to obtain rate data for the reaction shown? Colorimetry, electrical conductivity, mass change, or titration with alkali. So remember, continuous monitoring method. I have to monitor the reaction, whether the reaction is, you can say, fast and whether the reaction is slower. So I would say it's going to be electrical conductivity. I would say it's going to be electrical conductivity. You know why? In this reaction, there are ions. In the product side, you can see the number of ions. Okay. So the number of ions means what? When we would be having more ions, isn't it? When we would be having more ions, so there would be more electrical conductivity. When we would be having less number of ions, so there would be low conductivity. So I have to count the total number of ions. So in this way, I can monitor the rate of reaction. So that's why I have opted like electrical conductivity, right? So it depends on the equation, as in this question. In the given equation, the number of ions are given, so that's why I have decided to tick on option B. That's why, right? Then they are saying nitrogen dioxide is produced in the reaction shown, and the table shows the results of a series of experiments to measure the initial rate of this reaction. at 298 Kelvin. What are the orders of reaction with respect to NO and NO and O2? Okay, what would I do? What would I do? Let's say I have to find out the order of reaction with respect to NO, right? So I have to select experiment because this is totally changed. So initially I cannot find out the order with respect to NO first. No. Rather than this one, I'm supposed to find the order with respect to O2. You know why? Because this is the same data. So for the O2, I would select experiment 1 and 2. Okay. Let's say 0.0100 over 0.0050. This is the data for O2, right? 0.0100, 0.0050. I have copied the data, okay? And the power is x. That's the order with respect to O2, which is equal to 10.2 10 to the power minus 4 divided by 5.10 10 to the power minus 4. When I would be dividing it, right, 0.0100 divided by 0.0050, so it's going to be 2 raised to the power x. It's going to be 2 raised to the power x, right? So which is equal to 10.2 upon 5.10. Again, this is 2. They are cancelling each other. So x is equal to 1. So then the order with respect to O2 is first, like 1. So when I am going to check the options, so I would see that for the oxygen, first order, this is wrong, isn't it? So it may be A, it may be B. Now I have to see the order with respect to NO. Now what would I do? I'm going to take experiment 2 and 3. Let's say 0.0250 over 0.0125. This is going to be Y, the order with respect to NO, which I don't know, multiplied by 0.0200 over 0.0100. This is for O2, and I know the order of O2, that is 1, right, is equal to the rate, that is 81.6 exponent minus 4 divided by 10.2 exponent minus 4. Now I'm going to simplify this. Right? So 0.0250 divided by 0.0125, which is equal to 2 raised to the power x, multiplied by 0.0200 divided by 0.0100, the answer is 2, is equal to 81.6 exponent minus 4 divided by 10.2, that is equal to 8. So after simplification, I would be getting 2 raised to the power x is equal to 8 upon 2, that is equal to 4. So 2 raised to the power x is equal to, I can write 4 as 2 to the power 2. So they are cancelling each other, x is equal to 2. So this is second order. So the answer is B, because in B, the order with respect to NO is second. I'm getting second, and this is going to be first. I was getting first, right? Or they are saying the reaction shown is second order with respect to NO and first order with respect to O2 if the concentration of NO is doubled and the concentration of O2 is tripled. By what factor will the rate increase? Let me write down the rate equation first. As they have told us in the question, rate is equal to K into concentration of NO into concentration of O2, and they are saying second order with respect to NO and first order with respect to O2. Now you know what they are saying? They are saying that we have doubled the concentration of NO, like this, and we have tripled the concentration of like oxygen. So then they are asking by what factor the rate will increase. This is a very good question. Basically they are going to check your skills regarding when we increase or decrease the concentration, then how much the rate will increase. Of course it depends on the order of reaction, right? So I would say that 2 into 2 is 4 multiplied by 3 ones are 3, which is equal to 4 3s are 12. So the rate will increase by 12. So the answer is B for ball, right? Okay, in this way you can solve it. So for this question we are supposed to know about the order of reaction which they have told us in the question. Like they are saying NO is doubled, and they have told us second order with respect to NO, first order with respect to O2. So after this then we can solve it. It's very simple. Okay, this question is about the hydrolysis of okay. Then they are saying show that the data in the table are consistent with the SN2 mechanism for this hydrolysis of 2-bromo and then butane. 2-bromo and then butane, right? So now what would I do for this question? I have to first, SN2 means what? Second order. SN2 means what? Second order. SN1 means what? First order, right? So what I would be doing in this question, because we have to prove that the data in the table are consistent with the SN2 mechanism or not. So of course after finding out the order of reaction, it is supposed to be 2 because they are saying it should be consistent with SN2. So now I am going to find out the order of reaction with respect to OH and also with respect to you can say 2-bromobutane, right? Okay, so to find out the order with respect to 2-bromobutane, I am going to select experiment 1 and 2. Order with respect to 2-bromobutane. 2-bromobutane. I am taking shortcut, right? You are not supposed to do this. Experiment 1 and 2. So 0.300, right? And divided by 0.150. It means that I'm going to double it, isn't it? I'm going to double it. When I'm going to double it, so I have to check whether the rate is being doubled or not. Of course, the rate is also doubled. If you remember, I told you, when we double the concentration and the rate also doubles, it means that the reaction is first order. So I am supposed to write this is going to be first order, right? So you can also solve like that. 0.054 over 0.027. This is raised to the power x. So it's going to be 2. It's going to be 2. Cancellation, x is equal to 1. It's mean that the order with respect to 2-bromobutane is first order. Now I am supposed to find out the order with respect to hydroxide ion. Now the problem is that, again, as like the previous question, there is no same number. So what can I do for that? I am going to select an experiment. You can take 0 point experiment. If I select experiment 2 or 3, right? So for 2 or 3, 0.450 divided by 0.300, I know the order of 2-bromobutane, that is going to be 1. then 0.300 divided by 0.150. I don't know the order, I'm saying this is y. 0.162 divided by 0.054. Now let me just simplify this, right? So 0.450 divided by 0.300, so the answer is 1.5, multiplied by 0.300 divided by 0.150, so the answer is 2 raised to the power y is equal to 0.162 divided by 0.054, 0.054, so the answer is going to be 3. Let me just simplify this. 2 raised to the power y, 2 raised to the power y is equal to 3 upon 1.5. So 3 over 1.5 is equal to 2. Again the coefficients, again the base is same, I can cancel out, so y is equal to 1. So this is going to be first order. Yes, first and first, first and first. So the sum of 1 and 1 is 2. So the sum of 1 and 1 is 2. So I would say that this is going to be second order. Right, so I can write down the rate equation just like that. Rate is equal to 2-bromobutane raised to the power 1 hydroxide ion raised to the power 1, because I got 1 and 1. So if I can sum it up, I would be getting the 2. It means that the reaction is second order. Yes, the data is consistent with the SN2 mechanism, because after solution I am also getting 2, which means that the reaction is consistent. Okay, this is quite simple. Now this is 2024 June paper, and they are saying again the question is repeated, I think so. Yeah, bromate ions react with bromide ions in aqueous acid. Okay, the rate equation for the reaction is shown, right? Which continuous monitoring method could be used to obtain kinetics data for this reaction? If you remember, in the last question I have selected electrical conductivity just after looking at the ions in the product side. Now what can I do for this reaction? That's the reason, when we do topical past papers, so that's the good thing to do, because you are going to get the same number of questions to get an idea to do the comparison between the two same questions. Like some people think that all the time when we would be looking at this equation, so the answer would be the same, that is electrical conductivity. But no, we have to look at the reactants, we have to look at the product side, right? If you can see in this reaction, bromine is formed. Bromine is colored. If you remember, bromine is colored orange or brown shade, I think so. Yeah, in aqueous solution it's colored. When you see the colored species in the product side, so yes, I can say it's going to be colorimetry. It's going to be colorimetry. You can observe the color change. Is the color changing in a less amount of time? Is the color changing in a more amount of time? So you can take an idea and you can monitor the rate of reaction. So the answer is option A. Okay, what are the units for the rate constant for this reaction? Now I have to solve it. So I would say that let's say I'm going to take this one. So they are asking to find out the unit for the rate constant, that is K. So K is equal to rate, K is equal to rate, and this is going to be BrO3 negative, and this is going to be Br negative, and this is going to be H positive raised to the power 2. I know the unit for rate, that is mole per dm cube divided by mole per dm cube. I'm going to make it simple. So the power is 1, so the power is 1, the power is 2, overall power is 4. I'm writing 4, right? So it's going to be mole per dm cube per by mole 4 dm 4 3s are 12, dm 4 3s are 12. So then I'm going to simplify this. Mole 1 minus d plus 12 and then per second. It's gonna be mole minus 3 or dm plus 9 or per second. So the answer is going to be D for doctor. Right, simple. It's very easy. The concentrations of all reactants are halved. By what factor does the rate of reaction change? So you can see I have the rate equation, right? I have the rate equation. You can see they have given the rate equation. So after looking at this equation, I would say that after looking at this reaction, I would say that uh, let's say rate is equal to BrO3 negative, or what was that, Br minus, right, or Br minus or H plus squared. Same thing, right? Same thing. Now you have to put it as we did in the last question, if you remember. Now what I'm going to do, I'm going to like half it. So this is and by the way, the order with respect to BrO3 is negative, like 1, the order is 2, and the order is 1. Okay, so the overall order is what? 4. Now it becomes half, but the power is applied, it becomes 1 by 4, and also it becomes half. Now when I'm going to solve it, I would be getting 1 1s are 1, 1 1s are 1, 2 4s are 8, 8 2s are 16. So the answer is D for doctor. Simple, isn't it? Okay, the first 4 steps in this reaction mechanism are shown. What is the rate determining step? We all know that the rate determining step is the slowest step. So what can I do for that? I have to match this with the given rate equation. The first 4 steps in the reaction mechanism are shown. Okay, so can you predict it, like what is supposed to be the answer? I'm going to copy this one here, right? Okay, so that you can like do a comparison between the rate equation and the reaction mechanism, or I can say the slow step. Yes, yes. Okay, you know what can I do for that? Let's say I'm saying step number 1 is the slowest step. I'm supposed to write down the rate equation. Rate is equal to K into concentration of BrO3 negative into H positive. This is wrong. Because it's not matching with the given rate equation. Now I'm going to think that the step 2 is supposed to be the rate determining step. I'm supposed to write down the rate equation. So rate is equal to K into BrO3H into H plus, or but BrO3H is the product of this one, so it depends on this one and this one. So I'm supposed to replace it with BrO3 negative and H positive, right? And this H positive is the same like this one, and as like I did this one in the replacement of BrO3H just after looking at these two equations. Then I have found the overall rate equation, that is supposed to be this one. Yes, Can you match this with the given rate equation? No. So this is also wrong. Now you have to check step 3 whether it's supposed to be correct or not. So rate equation for step 3 is supposed to be K into BrO3H2 and Br negative. But when I saw this reaction, these 3 reactions, so remember this is which is in this equation, this is depends on this one or this one, so I'm supposed to replace it. So now I would not write this one, but I would write H plus and BrO3H, and Br minus would remain same, right? When I saw again, so BrO3H is depending on these two things. Now I would not write BrO3H, but I would write H plus BrO3 negative, H positive, and Br negative will remain same. When you will be simplifying this, so you will be getting K BrO3 negative, Br negative, H plus into H plus is square. You can see this is going to match with the given rate equation. So yes, step number 3 is the slowest step.